All right, so this part of the lesson or the topic, again, last lesson when we started surface area of composite shapes. So remember, composite shapes is two shapes put together. We didn't really go through pyramids. What we did go through, however, okay, were shapes like a house with a roof, or in this case, this is a marquee, like a tent. We also went through some of these shapes. That looks like a hairy cylinder. Sorry. So two rectangles or a triangle on top of a rectangle, okay? And then we also, if you can remember, we also went through the half pipe. Okay, so this is a composite shape because it's made up of a bunch of different shapes put together. So you've got a quarter of a cylinder, another quarter of a cylinder, rectangles, and some weird shapes here. So it's like a rectangle minus quarter of a circle. Okay, so we've got that to work with. And that's what we started on. And then we also did probably one of the trickier ones was finding the surface area of a cube that has a cylinder cut out in the middle. Okay, so with all of these shapes, these are all what you'd call composites. Okay, because they're comprised of more than one shape and they're all a bit different. Okay, you need to understand as well that you're only looking for the area of the surfaces that are exposed. So I think one of the analogies I used last week was that if you got the shape and you dipped it in some paint, it's the areas that are colored in. That's what you're looking for. The areas that are covered. So let's say, for example, I'll go back to this shape, the marquee shape. Okay, the areas that are covered here. So for example, if you've got a triangular prism and it's sitting on top of that rectangle, okay, that bottom part of the rectangle is going to be covering the top part of that rectangle. So it's covered. So you don't equate it or you don't add it. Similarly, the bottom part of the marquee, okay, is covered because it's just a marquee. So it's like a tent. There's nothing on the bottom. Okay. Jeremy and Jacob, you listening? Can you close your laptop, please? So remember, I want you to write some of this in your bound references because it's not in your notes. So what we're going to go through is similarly now surface area of pyramids, okay, but bearing in mind that these are going to be composite 3D shapes as well. So it's going to be a pyramid on top of another shape. Okay, so you've got to think about what is it covering, what area am I looking for if it's covered. And there's also obviously different types of pyramids. You've got pyramids with 3 sides or 3 triangular sides. Some have 4 sides. Others might have 5 or 6. Okay, but what we're going to try and find out or learn here is finding the surface area of your pyramids. We don't necessarily have to do the nets because I noticed that you guys, or this class at least, got very confused with how the nets work. So we can just stick to the basic shapes that we see. Okay, and then we're going to calculate, obviously, its surface area. So let's look at this here. Pyramids are named from their base shape. Okay, so when we talk about the base shape, we're talking about the bottom. Okay, what is the bottom shape? And what that will be the associated name of it. So for example, here, okay, it's got a triangular base. So for that first shape here, it's a triangular based pyramid. Right here, this is your typical pyramid. It's a square base, so it's a square based pyramid. And then you can have shapes like that where it's a hexagonal based pyramid. Now, we haven't really explicitly gone through how to find the area of a hexagon. So at most, what we will throw at you is probably just going to be your square base, your triangular base, and also maybe a rectangular based pyramid. Okay, so just be mindful of that. All right, so most pyramids, when you find the question that we give you in a sec, will have obviously one base. Okay, and depending on the number of sides on that base, that'll give you the same number of triangles that you'll be working with. So, for example, this square-based pyramid, you can see has a base that's a square, and then it's got four triangles. Okay, most of the time, the questions will only be a square base. Okay, so that means if you're trying to find the faces or the surface area, you're just finding the surface area of the base and the 4 triangles. That's it. Most of the time. Okay. Sometimes it might be a triangular pyramid, so it could look like this. It's a shoddy looking triangular pyramid. So that means if I was to unfold this, you'd have your triangle base. Okay, and then you'd have 1 triangle, 2 triangle, and then the 3rd triangle. Okay, triangle number 3. Okay, so 1, 2, 3. And you'll have the base as well that you need to look for. Okay. Okay, and if you need to figure out or remember what the formula of the triangles are, or whatever shape you are, remember at the start of this topic, I gave you this. Refer to this again if you need to figure out certain areas that you forgot. Okay, all right. Now, most pyramids, as you know, have a base, like I said, and also a height. So what you need to also remember is when you're working with a pyramid, is that it's a triangle, right? At the start of this topic, we looked at triangles, starting with P. Does anyone remember the theorem that we used?
Pythagoras.
Yeah, you're going to need to use Pythagoras as well for some shapes. Now, I'll show you how to put that in practice as we go, okay? Let's see, that's fine. All right, copy this into your bound references, okay? Because you will have a question like this in your bound reference or in your SAC. Okay, so copy this and let's try and find the area of it. If you don't know how to draw a pyramid, try and copy it as best as you can. But I found, drawing maybe the base first will help, and then you can draw your triangles like that. Okay, it's a bit tricky if you've never done it before, but try and copy it as best as you can. Also, we won't necessarily do the nets for these, but you will be doing a lot of drawing, okay, in order to find the areas. So just bear in mind that you need to be aware of the base so you know what kind of pyramid it is. In this case, there's 4 sides, so it's most likely either a rectangular base or a square base. And then there's obviously your 4 triangles. All right, so copy that down. Also, please copy down the measurements and the units there. So it's meters for both, 6 meters and 4 meters. I don't think we've thrown a question at you yet with different units, but it has happened in the SAC, so just keep that in mind. While you're going, does anyone know what these little lines mean? Good, it means that they're all equal. So even though some of the lengths are missing, okay, on the other sides, like here, here, and here, okay, because of that symbol, okay, those, which is the same as this 4 here, that means that these sides are all 4. So does anyone know what's the base of this pyramid? It's a square, because all sides of a square are the same. So it's a square-based pyramid. Thank you, Jamie. All right, let's find the areas of these. All right, for the square base, okay, let's just, I'm going to draw my little arrow there. So you can draw the face if you want to, or the shape. You don't have to, but if it helps you, okay, just draw it. So you know that this is 4, that's 4, and because we determined that this was a square face, or a square base, it's going to be all 4. Now the area of a square, remember, is length times length. You could also say length times width, but because it's exactly a square, it's going to be length and length. They're going to be the same. Rectangles are length times width. So this is a length times length. So it's going to be 4 by 4, which is 16 meters squared. So that's the first area, the base. Now, the second area that you're looking for here, I'll just zoom out a bit, okay, are the triangles. Now, just bear in mind, if you do have a rectangular base pyramid, not all of the triangles are going to be the same. In this case, because it's square base, you're going to have 4 triangles that are exactly the same. Okay, and I can see with this triangle, it's given me the height of the triangle already. Okay, so if I was to I'll find the area of this. So you've got a triangle that looks like that. It's got a base of 4 because, again, the base here, okay, corresponds to that triangle's base. So that's got a base of 4 and a height of 6. I might just draw the height like this. Okay, so 4 meters and 6 meters. Now keep in mind, because they're all the same, how many triangles do we have here? 4. So you're just going to multiply that by 4. So whatever your answer is, multiply by 4. So remember, the area of a triangle is base times height divided by 2. And then times by 4, because there are 4 triangles. So in that case, it's going to be 4 times 6 divided by 2 times 4. Okay, so 6 or 24 divided by 2, that should be 48. centimeters, meters squared. Okay, so there's my two areas. Okay, I've got my triangles. I've got my base, which is a square base, and then you just got to add them together. Okay, so that means the total is going to be 64 meters squared. Okay, just adding it all together as a final. So don't leave your answers as just these. In the SAC, it's going to expect you to obviously show your final answer. Although if you just left it as these, I would still give you some marks. But again, this total part here accounts for one full mark. So don't forget to put that in. Oops, sorry. All right, any questions with this so far? So it's pretty straightforward. Square base, most square base pyramids, you're just going to have a square and then 4 triangles that are the same. Okay. Let's do this one. So this one's slightly different. It is a square base. Okay, I'll leave that up there if you're still copying. It is a square base. However, now we've got some rectangles on the side as well to account for. So copy that in, and then we'll do this one together. Okay, so copy this question in. So be mindful again of the dimensions there. So you've got all the bases being 5, so all the lengths are 5 centimeters, okay? And you've got the length here of the rectangle, or you could say the height, depending on how you look at it, is 2, okay? The height of the triangle is 4. Also, because the base of the triangle shares that same base of the rectangle, okay, it's going to be, or you could say, sorry, the square, it's also 5. So that base of the triangle has to be 5. All right, so again, this is something you need to put in your bound reference, as it'll be a good one, sorry, to put in. All right, let's do this one. This one is pretty straightforward, okay? It's actually quite similar to the previous one. The only thing we're adding is there are these rectangular faces that we now need to also find the area of. But that's really it. Okay, that's essentially it. And they're all actually going to be the same because this is a square base pyramid. All right, so for the bottom of the pyramid, it doesn't say that it's not included, so we're just going to assume that it's part of it. The bottom of the pyramid, right there, hopefully that's not too confusing, but the bottom of the pyramid looks like this. It's got the dimensions of 5, 5, and 5. Because, again, like Jamie mentioned before, these lines mean they're all exactly the same. So if they're all 5, 5, 5, 5, you don't have to write them all. Just putting it for you. Okay, so that means the area of this is going to be length times length, which equals 5 times 5. So that equals 25 centimeters squared. Okay, the next side to look for now is these. Let's go for the sides of the square base, which is these rectangles. Okay, now remember these rectangles are exposed as well, and they form as part of the face. So we're going to try and find the area of it. You can draw it. Okay, so if that helps, draw the rectangles. Yes. 4. Okay, show me where the other side is, Sophie. Have a think about this shape. Remember, you've got the base. Is there any other faces that are exposed? Yeah, so you don't include the top because there's a pyramid on top of it. So you don't include it. Okay, so now we do the side, but let's go along that thought. Okay, what about this rectangle here? How many do we have? Have a think. You've got this side, you've got this side, you've got this side, and there's 4 sides, yeah? So you're going to multiply whatever your answer is by 4. So the dimensions are 2 centimeters and 5 centimeters. So length times width again, times it by 4 because there's 4 sides. So it's 2 times 5 times 4, which equals 40 centimeters squared. Okay, and the last one are these triangular faces. So again, there's 4 of them. Okay, so remember, you can draw it if you want to. I'll draw it for you guys. So the base is going to be 5 because all these bases are 5. It corresponds with the bases of the triangle. So we're going to use 5 as our base. And the height, okay, is 4 according to that diagram here, or that length there. So in that case, okay, remember base times height divided by 2. Oh, sorry, I forgot to mention there's 4 triangles. So you're going to multiply your answer by 4. Base times height divided by 2 times 4. So if the base is 5, the height is 4, divided by 2 times 4, and that will equal, no, what's that, 40 centimeters squared. Yeah. All right, and then from there, same procedure as the previous one, give me the total. So just add them all up in the end. Okay, so just going to add these 3. I think you remember in the previous examples I've done in other lessons, just circle your answers. So it helps you understand what you're going to add together. Okay, because when you do this in the SAC, I've found that a lot of kids put a lot of numbers in, but then they just get confused with what are they trying to add. So circle your answers so you know. So if you want, you can go total equals 25 plus 40 plus 40. And that'll equal 105 centimeters squared. Oh, that's the next part. Any questions with this? Pretty straightforward. I think a lot of the times, again, you're just trying to find the area of the base, and then if there's a shape like this, find the area of the rectangles. Okay, and then from there, find the area of the triangles. Maybe a little bit later on when you get to it, we might go through some of that Pythag stuff. Okay, so I'll stop there for now. But if there are no questions, I'm hoping that you guys are able to now do 6E, okay, from our textbook. And that